Somewhere past Jupiter tonight, there is a giant chunk of ice and rock flying through our solar system that is older than the sun itself, colder than anything in your freezer, and moving faster than any rocket humans have ever built could ever catch. Scientists expected to find just another comet. What they found instead was something that keeps breaking its own rules over and over again. Stick around, because by the end of this video, you are going to understand exactly why some of the top astronomers on Earth still cannot fully explain what this object is doing. And before we go further, tap subscribe if you want the next update on this story to land in your feed the moment new data comes in, because this object is still out there right now, still changing, and this channel will be tracking it. This is the story of 3I Atlas. It is a visitor from another star system, and it did not mean to stop by. It just happened to be passing through, the same way a stranger might walk past your house on their way somewhere else entirely. But this stranger carries secrets from a part of the galaxy so old, so cold, and so far away that nothing here has ever seen anything quite like it. Nobody sent it. Nobody aimed it at us on purpose. It simply drifted, unpowered and unplanned, for longer than most of us can honestly picture, until our own sun's gravity finally reached out and bent its path just enough to bring it briefly into view. In a very real sense, we got lucky. A few months earlier, a few months later, and every telescope on Earth might have missed it completely. Astronomers first spotted it in the summer of 2025, and at first it looked completely ordinary. A faint smudge of light, a dot on a screen. Nobody in that control room knew they were looking at only the third object ever confirmed to have come from outside our solar system. Not the third comet, not the third asteroid, the third visitor, ever, from another star. By the time you finish this video, you will know why this comet is being called one of the oldest things human eyes have ever laid eyes on, why it started glowing a strange color scientists did not expect, and why a small but serious group of researchers still have not ruled out the strangest explanation of all. Let us go back to where this story actually begins. Most people, if they have heard of this comet at all, believe it just showed up out of nowhere, a random speck that surprised everyone overnight. That is not quite right. Astronomers had actually caught faint traces of this object in old telescope images taken weeks before anyone noticed it, sitting there quietly, waiting to be found. The truth is not that it appeared suddenly. The truth is that it had been hiding in plain sight, and nobody had looked closely enough yet. On July 1st, 2025, a robotic sky survey system called ATLAS, which stands for the Asteroid Terrestrial Impact Last Alert System, caught the object using a telescope in Rio Hurtado, Chile. ATLAS is basically a set of robotic eyes that scan the entire night sky, every single night, looking for anything moving that should not be there. It is the same kind of system built to warn us if a dangerous asteroid is ever heading toward Earth. That night, it caught something moving in a way no ordinary asteroid moves. The system is funded by NASA, and it runs almost entirely without a human sitting there watching in real time. Instead, computers compare thousands of new images against older ones, every single night, hunting for tiny points of light that have shifted position even slightly. Most nights, that search turns up nothing unusual at all. On this particular night, it turned up an object moving on a path that simply did not match anything born inside our own solar system. Once astronomers checked older photographs, they found the object had actually been sitting in the data since May 7, 2025, almost 2 months earlier, too faint and too far away for anyone to notice until the software finally connected the dots. Think about that for a second. It is a bit like realizing a stranger has been standing quietly at the edge of a party for almost 2 hours before anyone finally turned around and said, "Wait, who is that?" This kind of digging backward through old images is called precovery, and it happens after almost every major discovery in astronomy. Once scientists know exactly where and when to look, they can search through archives from other telescopes around the world, hunting for that same faint dot hiding in images nobody had reason to examine closely before. In this case, that search stretched the object's known timeline backward by 55 extra days, giving researchers a longer, clearer picture of exactly how it was moving before anyone even knew it was there. Here is the underdog part of this story. When 3I Atlas was first confirmed, most scientists assumed it would be small, boring, and forgettable, just like a distant cousin of the two interstellar objects found before it. The first one, called Oumuamua, was spotted in 2017, and it was strange, but tiny, and gone within weeks. The second, called Borisov, showed up in 2019 and behaved like a normal, sleepy comet. Nobody expected the third one to be any different. They were wrong. Oumuamua was so small and so quiet that most telescopes on Earth could barely hold on to it before it vanished back into the dark, like trying to keep your eyes on a single firefly crossing a football field at night. Borisov was brighter and easier to study, but it acted almost exactly like the comets we already knew, releasing gas and dust in a familiar, predictable way. Nothing shocking, nothing new. After those two, plenty of scientists assumed the third interstellar visitor, whenever it finally showed up, would simply confirm what they already believed. Comet 3I Atlas had other plans. The first surprise came almost immediately, once scientists calculated its path through space. A normal comet from our own solar system moves in a closed loop, like a racetrack that curves back around the sun again and again, sometimes for thousands of years. Comet 3I Atlas was not doing that. Its path was what scientists call hyperbolic, which just means it is a straight, one-way road with no loop at the end. Scientists expected another visitor that might, maybe, one day circle back. What they found instead was a one-way ticket, a path that comes in once and then leaves forever, never to return. That is like a guest walking through your front door, and you realizing the only door in the house is also the only exit, and once they leave, they are simply gone, for good. Think about the silence of that kind of journey. No engine roaring, no sound at all really, since sound cannot travel through the emptiness of space. Just billions of years of drifting quietly through the cold, dark gap between one star system and another, patiently, endlessly, until gravity from our sun finally bent its path just enough to bring it briefly, one single time, into view of anyone paying attention. The second finding changed everything scientists thought they knew about how old this object might be. Researchers using the European Southern Observatory's Very Large Telescope in Chile studied the type of water locked inside the comet's icy body in January of 2026. Water is not just water out in space. Some of it is a heavier version, built with a different kind of hydrogen atom, called deuterium. The amount of that heavier water tells scientists how cold and how old the place was where the ice first formed. Scientists expected levels similar to comets from our own solar system. What they actually found was nearly 30 times more of that heavy water than normal. That is the difference between water from your kitchen tap and water that has been sitting untouched in the coldest, darkest corner of a walk-in freezer for billions of years. Heavy water like that only builds up in places that are extremely cold and that have had an extremely long time to sit undisturbed. It is not the kind of chemical fingerprint you get from a young, busy star system still actively forming planets. It is the kind of fingerprint you get from somewhere quiet, somewhere forgotten, somewhere far from the noisy center of a galaxy, where ice can sit for billions of years without anything nearby to warm it up or stir it around. Do you think scientists will ever pin down exactly where in the galaxy this comet actually formed? Drop a comment below with your best guess, because comments like that genuinely help me figure out which parts of this mystery you want me to dig into next. Based on that ancient chemistry, astronomers now estimate that 3I Atlas could be up to 11 billion years old. Our own sun is about 4.6 billion years old. That means this comet may be more than twice as old as the star it is currently flying past. Picture something that formed before our sun even existed, drifting silently through the galaxy for billions of years, only to finally pass close enough for us to notice it, just once, this year. Here is where the domestic and the cosmic collide. 11 billion years is such an enormous number that it stops meaning anything real to most of us. So picture it like this instead. If the entire history of the universe were squeezed into one single calendar year, this comet would have started forming sometime back in early spring, and human beings, all of recorded human history, would not show up until the last few seconds before midnight on December 31st. That is the kind of age we are talking about here, wrapped around a piece of ice small enough to fit inside a mid-sized city. The third discovery puzzled scientists the most, and it involves the comet's tail. Comets almost always grow a tail that points away from the sun, because sunlight and solar wind blow the dust backward, the same way wind blows smoke away from a candle. On July 21, 2025, the Hubble Space Telescope captured an image of 3I Atlas showing a faint glow pointing the wrong way, toward the sun instead of away from it. Scientists call this an anti-tail, and normal comets are not supposed to have one that behaves quite like this. David Jewett, an astronomy professor at UCLA who has studied comets for decades, offered a fairly grounded explanation. He suggested the comet's sun-facing side was heating up and throwing off dust in that direction, since that side gets hit hardest by sunlight, similar to how the side of a stove closest to the flame heats up first. It is a completely natural process. But it was still something researchers had never quite documented this clearly on an object from outside our solar system before, and that alone made it worth studying closely. Picture standing near that surface, if you somehow could. One side would be baking under raw, unfiltered sunlight, hot enough to turn solid ice directly into streaming gas and dust. The other side would sit in absolute darkness, colder than any freezer on Earth could ever get, holding onto ice that has not felt warmth in billions of years. That kind of split, one face burning, one face frozen solid, helps explain why the dust ended up glowing in a direction nobody initially expected. As 3I Atlas got closer to the Sun, the numbers scientists were tracking got sharper and stranger. The comet reached its closest point to the Sun, called perihelion, on October 29, 2025, at exactly 11:45 Universal Time. At that moment, it was traveling at roughly 68 kilometers per second, which is close to 152,000 miles per hour. To put that in perspective, that is more than twice as fast as the fastest rocket ships humans have ever launched into space. Nothing we have ever built could catch up to this comet, let alone stop it. Around this same time, engineers at NASA's Jet Propulsion Laboratory, tracking the comet's exact position day by day, noticed something odd. A navigation engineer named Davide Farnocchia recorded a tiny but measurable extra push on the comet's path, something not fully explained by the Sun's gravity alone. Scientists call this a non-gravitational acceleration, and it usually just means gas is escaping from the comet's icy surface and acting like a very gentle, very natural thruster, nudging the object ever so slightly off a purely gravity-only path. The measured push was incredibly small, about 1/20th of a millimeter per second, added again and again, day after day. That sounds like nothing at all. But across millions of miles of empty space, tiny nudges like that can shift a path in ways that are absolutely measurable with the right instruments. It is the same idea as leaning very gently against a giant door for hours. Eventually, that tiny, steady push actually moves something enormous. What makes this measurement so impressive is not the size of the push itself, but the precision required just to notice it at all. Engineers were tracking an object moving at over 150,000 miles an hour, from hundreds of millions of miles away, and still managed to detect a nudge smaller than the width of a human hair moved over an entire day. That is the kind of careful, patient measurement that normally never makes headlines, even though it is exactly the kind of work that made every other discovery in this story possible in the first place. Are you the kind of person who finds these tiny hidden details more interesting than the big flashy headlines? If this video is doing that for you, hit like and let me know in your own way, because it genuinely helps this story reach more people who enjoy digging into the details as much as we do. Now let us talk about the color, because this is where things got genuinely unexpected. As 3I Atlas approached the Sun and started heating up, most comets turn a bit redder, because the dust they release tends to scatter sunlight in a reddish way, similar to how smoke can look warm and orange in certain light. Scientists expected 3I Atlas to follow that same pattern as it warmed up near perihelion. What they actually observed instead was the comet brightening faster than predicted and turning distinctly bluer, not redder, right around its closest approach to the Sun. That single unexpected color shift is part of what opened the door to some genuinely wild speculation. Harvard astronomer Avi Loeb, who has built a career studying unusual objects passing through our solar system, has openly raised the possibility that some of this comet's strange behavior could, in theory, be explained by something artificial, rather than purely natural. To be clear, this is a minority position, and most researchers studying the object do not agree with it. But Loeb has pointed to the unusual blue color, the anti-tail, and the tiny, unexplained acceleration as a combined pattern worth taking seriously enough to keep investigating, rather than dismissing outright. This is still debated among scientists, and it is worth being honest about that instead of pretending the debate does not exist. The vast majority of the astronomy community, including the teams running the world's largest telescopes, currently interpret 3I Atlas as a natural, if unusually large and unusually old, interstellar comet. The non-gravitational push, the odd tail, and the color shift can likely all be explained by ordinary outgassing physics happening on a scale we simply have not observed this clearly before. But a small number of scientists argue the models had predicted something slightly different than what was actually measured, and they believe that gap deserves more scrutiny before anyone closes the book on this object completely. To settle at least part of that question, researchers turn to one of the most sensitive listening tools on the planet. Using the Allen Telescope Array, a network of radio dishes built specifically to search for possible signals from other civilizations, scientists pointed their instruments directly at 3I Atlas and listened. They were searching for what scientists call technosignatures, which just means any kind of signal, any kind of transmission, that could only come from technology rather than nature. The search came back completely silent. No transmissions, no structured signals, no technosignatures of any kind detected coming from the comet. For most researchers, that silence was reassuring, another solid piece of evidence pointing toward a natural explanation rather than an artificial one. It does not fully end the conversation for everyone, but it does meaningfully narrow it. Imagine standing in the quietest room you have ever been in, straining to hear even the faintest hum, and hearing absolutely nothing at all. That is roughly what this radio search felt like on paper, dish after dish, hour after hour, tuned to a distant, drifting piece of ice, listening for anything that did not belong there. Nothing came back, just the ordinary static of empty space, the same static that has always been there, and probably always will be. Would you have expected scientists to actually point a radio telescope at a comet and check it for alien technology? Let me know in the comments, because reactions like that genuinely tell me how much extra context to include the next time a story like this comes up. While the radio search was happening, an entirely different team was digging into the comet's chemistry using one of the most powerful telescopes ever built. In June of 2026, a study published in the journal Nature, led by researcher Martin Cordner at NASA's Goddard Space Flight Center, used the James Webb Space Telescope's NIRSPEC instrument to analyze light passing through the gas cloud surrounding the comet, called its coma. That gas cloud forms when ice on the comet's surface warms up and turns directly into gas, similar to how dry ice smokes at room temperature here on Earth. Scientists expected the ratio of methane to water inside that gas cloud to look roughly similar to comets we already know from our own solar system. What they actually found was a methane to water ratio roughly 11 times higher than anything ever measured on a comet born here at home. That is the difference between a recipe using a small pinch of one ingredient and a recipe using nearly a full cup of that same ingredient instead. Something about the environment where this comet formed baked in an entirely different chemical mix than anything nearby space has ever produced. For comparison, methane is the same simple gas that quietly powers a stovetop burner in a kitchen right here on Earth. Finding roughly 11 times more of it locked inside a piece of ancient interstellar ice is a bit like discovering a neighbor's pantry stocked with 11 times more of one particular spice than anyone else on the street keeps in their kitchen. It does not mean anything sinister. It just means that whatever star system first mixed this comet together used a very different recipe than the one that built our own solar system. Researchers at the Subaru Telescope in Hawaii added another piece to this puzzle in January of 2026, publishing their findings in the Astrophysical Journal. By studying light from deep inside the comet's glowing coma, right after its closest pass by the sun, they measured the ratio of carbon dioxide to water hidden in its interior, not just its outer crust. That inner ratio turned out to be noticeably lower than earlier readings taken from its surface layers alone, suggesting the outside of this comet has been slowly cooked and altered by billions of years of exposure to cosmic radiation, while the deep interior stayed more like a frozen time capsule underneath. Picture that for a second. The outer shell of this comet has spent billions of years getting slowly weathered by radiation in deep space, the same way the outside of an old book left in sunlight can fade and crumble, while the pages tucked deep inside stay perfectly preserved. Scientists are essentially peeling back layers of ancient time, one telescope observation at a time. There is something almost quiet and personal about that idea. A crust, battered and changed by billions of years alone in the dark, wrapped protectively around a core that somehow stayed closer to its original state, untouched, waiting. It took a telescope on a mountaintop in Hawaii, watching patiently in January of 2026, to finally read even a small part of what that inner layer had been holding onto for so long. As of the middle of 2026, 3I Atlas has already swept past the Sun and is now heading back out into deep space, currently somewhere beyond the orbit of Jupiter. It has faded to a magnitude fainter than 15, meaning it is now far too dim for anyone to see with a backyard telescope, let alone the naked eye. It will keep getting fainter and farther until it eventually slips beyond the reach of even our largest instruments completely. And that leads to the part of this story people tend to feel the most. This comet is never coming back. Its hyperbolic path guarantees that once it leaves for good, sailing back out into the space between the stars, carrying its ancient ice and its unanswered questions with it, forever out of our reach. If this story has genuinely surprised you at any point in the last few minutes, would you consider sharing it with one person you know who loves space, science, or a good mystery? Sharing helps stories like this one actually reach the people who would enjoy sitting with these questions as much as you just did. Scientists will tell you, honestly and without embarrassment, that they do not fully understand everything about this object yet. There is a fourth puzzle here too, one that has quietly frustrated researchers more than almost anything else in this story, and it comes down to a very simple question that nobody can fully agree on yet. How big is this thing, really? Scientists expected two different methods of measuring the comet's size to land somewhere close to the same answer, the way weighing yourself on two different bathroom scales should give roughly the same number. What they actually got instead was a real disagreement. One method, based on how the comet's path bent slightly under its own gravity and the pressure of escaping gas, suggested a massive core, weighing somewhere north of 33 billion tons, far heavier than either interstellar visitor found before it. A separate method, based purely on how much sunlight the object reflects back toward Earth, pointed toward a noticeably smaller, lighter body instead. That is the difference between guessing someone's weight by how hard the floor creaks under their footsteps versus guessing their weight just by looking at how much space they take up in a doorway. Both methods are reasonable, both are backed by real data, and yet, pointed at the exact same object, they are not fully agreeing with each other. That gap has not been closed yet, and researchers are openly working through it rather than pretending it has already been solved. That kind of open disagreement is not a failure of science. It is actually what good science looks like while it is still happening in real time, before all the data has been fully processed and cross-checked. Every new telescope observation adds another small piece, and sometimes those pieces do not fit together cleanly on the first try. That is normal. That is how discovery actually works, messy and incomplete, right up until the moment it suddenly is not. Most of the biggest breakthroughs in the history of astronomy went through this exact same messy middle stage, full of disagreements, competing measurements, and researchers openly comparing notes before anyone reached a confident, shared conclusion. 3i Atlas is simply going through that stage right now, in public, with the whole world able to watch the process unfold in something close to real time, instead of waiting years for a tidy, finished answer. So where does that leave us? We have a piece of ice, quite possibly older than our sun, that formed in some cold, forgotten corner of the galaxy long before Earth ever existed. It carried strange water, strange gas, and a strange, unexpected color shift across millions of miles of empty space, only to pass close enough for a handful of scientists on a small blue planet to notice, measure, and argue about, for one brief window of time, before it disappears again forever. We still do not know the exact star system it came from. We still do not fully agree on its exact size or its exact mass, and a small handful of researchers still have not completely ruled out the strangest explanation floating around this story. But none of that uncertainty is a weakness. It is simply where the science currently stands, honestly reported, with more telescopes still pointed at the data even now, long after the comet itself has already started fading from view. Let us go back to that very first idea for a moment, the one about something that should not exist flying quietly past us. What did not seem expected then makes a lot more sense to you now, because you understand the pieces behind it. A comet older than the star it is passing, a path that only ever goes one direction, a color shift nobody predicted, and a silence from the radio telescopes that quietly reassured almost everyone listening. Here's the part that is easy to miss in a story this big. While this comet was flying past, humans on a small planet noticed it, tracked it, measured its water, listened for its signals, and argued carefully about what it all meant. That is not a small thing. Out of billions of years and trillions of miles, this particular rock happened to cross paths with the particular few decades when we finally had the telescope sharp enough and the curiosity strong enough to actually notice. Somewhere out past Jupiter right now, 3i Atlas is still moving, still fading, still carrying its ancient ice back out into the dark. It will not slow down. It will not circle back. It came from somewhere impossibly distant, passed close enough for us to finally look up and pay attention, and now it is leaving again, this time for good, taking its unanswered questions with it into the space between the stars. And maybe that is the part worth sitting with tonight. Not the exact mass or the exact color, or which theory eventually turns out to be correct, but simply this. Somewhere out there, right now, something ancient just quietly reminded us how small our little corner of the universe really is, and how much is still passing by, unnoticed, waiting for someone curious enough to finally look up. At the start of this video, that opening image probably sounded almost impossible, a piece of ice older than the sun, drifting past us like it was nothing at all. Now it does not sound impossible anymore. It sounds like exactly what it is, patient evidence that the universe has been quietly building and hiding stories long before we ever existed to notice them, and that it will likely keep doing so long after we are gone, too. Few people were even watching the sky closely enough to catch this comet in those very first faint images back in the spring of 2025. But once the data was there, once the pattern was confirmed, it stopped being a private discovery for a handful of astronomers and became something the whole world could quietly look up and wonder about together. That shift, from a handful of eyes to millions of them, is part of why stories like this one matter. So the next time you step outside at night, and the sky looks calm, familiar, almost boring, remember that somewhere out past Jupiter, an 11-billion-year-old traveler is still sliding silently through the dark, carrying secrets we only just barely started to read. We will probably never see anything quite like it again, and that, more than any single number or measurement, is worth carrying with you tonight.